So here what we are doing in this video, uh, we are transferring 16 bytes of data stored at memory locations 2050 to 205F in hexadecimal. These are the memory locations, and from here the data is to be transferred in the memory locations starting from 2070. So uh, here we would use the LXI instructions, which basically loads a memory address in the register pairs. Further, we would also use the MVI instruction, which is immediately moving data into one of the registers to set up a counter. Then here we will also illustrate the use of the jump instruction using the zero flag, and we will set up a loop. So let's go about doing this. Right now, first of all, we have to store our data in the memory locations starting from 2050 to 205FH. I have already done this. I hope you know how to do this. Right. Now we would just check that our data is present at our memory locations. Right. Our data, the 16 bytes of data are 37, A2, F2, 82, 57, 5A, 7F, DA, E5, 8B, A7, C2, B8, 10, 19, and 98. So 205FH is the last memory address uh, from which the data is to be transferred into another memory address. Here we would use the indirect addressing mode. The advantage of the indirect addressing mode is that the register pair, the memory locations in the register pair can be incremented or decremented, as a result of which we would save a significant amount of programming steps. So let's get started. First of all, what I will do is I will store the memory location 2050H into the HL register pair. To do this, what I will do is I will use the LXI instruction. LXI stands for load into the register pair. To load a memory location into the register pair, it is a 3-byte instruction. So the OP code, and I will begin the program execution from the memory location 2000. Right. So what I do is examine memory and 2000, and right, I would begin the program execution from the memory location 2000. The OP code for LXI is 21, so I store 21 here, and LXIH we have just confirmed. Our operand is the memory location from which the data is to be transferred into another memory location. So the lower byte goes first, so the lower 2 bytes go first. So 50 goes first, and then 20 goes, right. Then our instruction is to store the memory location to which the data is to be transferred into the DE register pair. For doing that, I will use the opcode 11, which is the opcode for LXID, load into the DE register pair, and then the memory location. Memory location is 70 and 2070, so higher byte goes afterwards. Right now, what I will do is I will set up the counter. For setting up the counter, I will choose a register, and I will uh, move the hexadecimal number in the register, or rather the decimal count of 16 in the register. The corresponding hexadecimal number is 10H. So the next memory location is 2006, and I will use the MVI instruction whose opcode is 06, MVI to B, and I would move the number hexadecimal number 10, which when converted into decimal is 16. Note that when we use the decrement instruction, the hexadecimal number gets decremented by 1. So after 10, it goes to 0F, right? And in after 16 steps, all the way it goes to 0 0, and after that our loop comes to an end. Right, next I set up a loop. For the loop, in the loop, what I do is I transfer the contents of the HL register pair into our accumulator. Right, because first we would transfer the contents into our accumulator, and then from the accumulator we would transfer the contents into the memory location which is present in the DE register pair. We can't directly transfer the contents of a memory location present in the HL register pair to the contents of the memory location present in the DE register pair. So accumulator needs to be involved, right? So I set up a loop, and in that, first of all, we transfer the contents to the accumulator. So the memory location is 2008, and the opcode is 7E, right? 7E, and this is move a comma m, transfer the contents from the source memory into the accumulator. And then we have to specify our source memory, or rather the HL register pair is already specified when we write move a comma m. Right, now we store from the accumulator into the register pair. So the instruction uses stax, stored from the accumulator into the register pair. Opcode is 12. Right, we can check, and it stores the contents present in the memory location into the DE, into the memory contained in the DE register pair. Right, now we have stored our data from the HL register pair into the DE register pair. We have to do this 16 times. So what we do is we increment the memory location present in the HL register pair, we increment the memory location present in the DE register pair, and we decrement the counter. Whenever the counter hits 0, we stop our execution and exit the program, right? So for that we have to first increment our HL register pair. For that I use the opcode 23, increment X. Then I increment our DE register pair, opcode 13, increment D. Then what I do is I decrement the counter, opcode 05, decrement B. Right, now if the counter reads 0, we have to exit, but if the counter doesn't read 0, we have to jump to the memory location from which the loop has started, right? So the jump instruction opcode is C2, so JNZ, right? JNZ, and the address where we have to jump, that is the starting address of the loop, is 082008. The lower byte goes first, and next the higher one, so 2008. Then we simply give a halt, because whenever the content of the counter hits 0, our program execution should end, right? So thus we are done with our program. Now I press reset, then go and start the execution of our program, and then execute, halt and counter at 2010, and we can see the counter which we had stored in the register B has hit 0, and we can successfully conclude that our loop has run 16 times, right? Now if I have to examine the contents of our memory location starting from 2070, what I do is I press go, 2070, examine memory. So 37, A2, F2, 82, 57, 5A, 7F, DA, E5, 8B, A7, C2, B8, 10, 19, 98 were the contents of the memory location from 2050 to 205FH, and the same contents are repeated in the memory location starting from 2070 to 207FH. Thus we have illustrated indirect addressing modes and the use of increment and decrement operators in order to simplify our program greatly. Thank you.